All right, today we're going to do section 7.2, day 1, which is finding inverse trig values. To find the inverse of a trig function, either x or y, you have to make sure that you are in that restricted domain. So we spent a lot of time the last 2 days talking about the domain where we restrict it. We graphed it. We talked about how to make it pass the horizontal line test, and that's how we came up with those values. So for sine, our domain is restricted between negative pi over 2 and pi over 2 for the angle measures. And then our ratio is sine has to bounce between negative 1 and 1. Now remember, when we find the inverse, those domain and range flip. So the angle becomes our range, and then the restrictions on the ratio becomes our domain. Well, the same thing happens for cosine and for sine. Okay, so remember, for cosine, our restricted domain is 0 to pi, and then your ratio, the restriction on the ratios is negative 1 to 1. And then again, for the inverse, that just flips. And then for tangent, it's negative pi over 2 to pi over 2. But remember, those are asymptotes, so it's parentheses there. And then our range is all reals, or negative infinity to infinity. So there's two ways to visualize it. So for sine and tangent, if we think about negative pi over 2 down here, all the way up to pi over 2, we know we're looking in on the right side of the graph. We're looking in quadrant 1, and we're looking in quadrant 4. So in order to name the inverse sine of a function or the inverse tangent, we have to make sure that those restrictions are on the right side of our graph, quadrants 1 and quadrant 4. And again, if we're in quadrant 4, we have to make sure those values are between 0 and negative pi over 2. So if it's an angle down in quadrant 4, we've got to make sure we refer to it as a negative angle. Okay, cosine is restricted from 0 to pi, right? All the angles are restricted from 0 to pi. So cosine only has inverse functions in quadrant 1 and quadrant 2 when we're looking for those angles. Okay, so sine and tangent have to be from negative pi over 2 to pi over 2, so in quadrants 1 and 4, and then cosine from 0 to pi. All right, so one of the things that we talked about previously is that when we take the inverse of a function, the whole idea of the inverse and the function is that those undo each other, and we get x. And if we do it the other way, we take the function of the inverse function. Again, those undo each other, cancel each other out, and we end up just getting x. So we're going to do the same thing today, except for we have to follow our domain restrictions. So if we have sine inverse of sine, one of the things we have to remember is that anytime we have sine, it has to be followed by an angle. So in order, as long as that angle is within our domain restriction for sine, these two will undo each other and we'll end up with just the angle. All right, anytime we have sine inverse, like in our homework the last couple days, sine inverse, that has to be a ratio. So as long as that ratio for sine is between negative 1 and 1, then those will undo each other and our answer is just that value. Same thing happens for cosine and tangent. It has to be within those restrictions. One of the big things I want you to remember, though, is that sine is always followed by an angle, and then that answer is always a ratio. And if it's sine inverse, that has to be a ratio, because remember that y becomes the x, and then that answer is an angle. So those are just some important things to remember from yesterday. All right, so we've got some steps to evaluate the composite functions that have composite functions and their inverses. Okay, so the first thing we have to do, like I was just mentioning, determine if the input is either an angle or a ratio. Okay, and after we figure out if it's an angle or a ratio, we basically have a few different options. If the input is an angle and it's in that restricted domain that we were just talking about, the two functions undo each other and we're left with that angle. Okay, if the input is an angle and it's not in the domain, that's where we're going to have to manipulate, kind of like what we did on the first day of the inverse trig. We're going to change that angle until we have an angle that has the same sine or cosine or tangent value, but it has to be within the restricted domain. All right, so we can rewrite angles only if the input is a ratio, so if it's a 1/2 or 3 over 2, and if it's within the domain, then the functions undo each other and we're left with that value. If it's a ratio that's not in the domain, we cannot rewrite ratios, so that one just doesn't work and our answer is undefined. So if we were doing sine inverse and it was outside of negative 1 to 1, so say it was 2.5, that answer would be undefined. You cannot rewrite ratios. We can only manipulate angles. All right, so let's take a look at a few. So again, anytime we have sine inverse, I know this is a ratio. Okay, so the restriction for sine for its ratios is -1 to 1. Since -1/2 is between -1 and 1, those undo each other, and our answer is just -1/2. All right, cosine inverse. Again, if it's cosine inverse, that means the following has to be a ratio. And we know for cosine, it has to be -1 to 1. Okay, so √3/2 square root of 3 is 1.7. 1.7 cut in half is 0.8-ish, 0.85. So I know that that's between -1 and 1. So again, because it's between -1 and 1, those undo each other. And our answer is just -√3/2. All right, going down to tangent. Tangent's the easy one because tangent has no restrictions, right? Our range for tangent is -π/2 to π/2. So since this is a ratio and it has to be from -infinity to infinity, and it is from -infinity to infinity, I didn't mean to say -π/2 a few seconds ago. Since this is from -infinity to infinity, those undo each other and we just get -12. Okay, so some of you are thinking this might be it seems too easy to be true. And again, those are very easy ones because they all were within that restricted, the restricted values for the ratios. Okay, if for some reason this would have been -12, well, -12 isn't between -1 to 1, and our answer would have been undefined. Okay, so the ratios are usually the easiest one, which is why I wanted to start with those. All right, so let's take a look at some that are angles. So again, every time we have sine or cosine, obviously this measure is an angle. Okay, for sine, our restriction of angles is -π/2 to π/2 with brackets, and π/3 is between -π/2 and π/2. So that's the easy one. Since it's within that domain restriction, those undo each other, and our answer is just π/3. All right, so again, one way to visually look at it is we're looking from -π/2 to π/2, and we know π/3 is right there in quadrant 1. So those undo each other. That is an easy one. Okay, now cosine. Again, cosine is always followed by an angle, but the restrictions for cosine are a little bit different. Those are 0 to pi for our angles. Well, since pi would be 6/6, right? 6π/6, and this is 5π/6. That is within the 0 to pi range. So then these undo each other, and our solution is just 5π/6. Okay, so again, you're probably thinking, wow, this is really easy. Now we're going to get to the more difficult ones. All right, so tangent, inverse, and tangent. So again, since follows tangent, this has to be an angle. And we know for tangent, we're looking from -π/2 to π/2 with parentheses because the asymptotes are at π/2 and -π/2. So we have a problem here because this angle right here in the middle is not from -π/2 to π/2. Okay, so we've got to figure out where is 11π/6. So let's label our triangle. I know this is 0. I know this is 6π/6. Up here would be 3π/6. Add them together to get the bottom, we get 9π/6. And 2 pi would be 12π/6. Okay, so I know that 11π/6 is right here. We talked a lot about reference angles on the first day. So because it's an angle, I'm going to scroll back real quick and look at the directions. Because our angle was not in the domain, we can manipulate it and rewrite it so that we can get it within the restricted domain. Okay, the only thing we have to be careful with is I have to replace 11π/6 with an angle that has the same trig ratio. Okay, so we talked about this the other day. Tangent in quadrant 4, we have it as 11π/6. Well, the problem is when we look at tangent, we look in quadrants 1 and 4. However, we cannot refer to this as 11π/6 because remember, we need to be from -π/2 to +π/2. So all we have to do is we have to rename this angle. Instead of calling it 11π/6, if I go negative, right, how much? Well, from 12π/6 to 11π/6, I can call that -π/6. 11π/6 and -π/6 are in the same location, so they have the same tangent value. So all I have to do is I have to cross out that 11π/6, And I'm going to rewrite this as inverse tangent of tangent, and I'm going to rename 11 pi over 6 negative pi over 6. So now you have to ask yourself, is that negative pi over 6 within my restricted domain from negative pi over 2 to pi over 2? And it absolutely is. So my answer is negative pi over 6. So all I had to do is I had to rewrite that angle. Since it was already in those restricted quadrants, it was just called the wrong thing, right? 11 pi over 6 is too big. All right, so let's try one very similar to it in the next example, letter D. So I know that after cosine has to be an angle, and I know cosine's restrictions are 0 to pi. Well, if I'm talking 6 is pi, and 11 pi over 6 is way too big. Okay, so again, I know where 11 pi over 6 is. 11 pi over 6, we just did that. This is 12 pi over 6, or 0. This is 3 pi over 6. This is 6, and this is 9 pi over 6. Throw those pi's in there. So I know 11 pi over 6 is down here. So here's where we get into a little bit more difficult question. I know that cosine has to be up in quadrants 1 and 2. So just like we did on Monday, I have to find an angle that has the same cosine value, and we know cosine is x, so has the same x value as 11 pi over 6. Well, that means I need to find my reference angle, and I know my reference angle is pi over 6. Remember, it's how far is it from the x-axis, and it always has to be positive. So now we got to figure out where else does cosine have the same x value as negative pi over 6. Well, cosine's positive in quadrant 4. It's also positive in quadrant 1. These would have the same x value. So I'm going to use my reference angle of pi over 6. So I know that cosine of 11 pi over 6 and cosine of pi over 6 have the same value. So like I said before, we're going to take that cosine. We're going to get rid of it of 11 pi over 6. And I'm going to rewrite it as cosine inverse of cosine of pi over 6. And now that pi over 6 is in with that restricted domain, the cosine and the inverse, or inverse cosine and cosine, undo each other. And my final answer is pi over 6. Pi over 6 is from 0 to pi, so it's in with that restricted area. All right, let's take a look at another one. 17 pi over 4, and we're talking this time about sine. Okay, so let's draw our picture. We've got fourths this time. So I know pi, that's 4 fourths. This is 0. And this would be 8 fourths. This one's not so bad. This would be 2 pi over 4. Add them together gets me 6 pi over 4 down here. So I know right away that because it's sine, this has to be an angle. And this angle has to be from negative pi over 2 to pi over 2. Well, clearly 17 pi over 4 is way beyond pi over 2, because pi over 2 we said was 2 fourths. Okay, not only that, it's beyond 2 pi, and we know 2 pi is 8 fourths. So what we have to do is we have to do some subtraction here. We want to find a coterminal angle. So if I subtract 8 fourths, that gives me 9 fourths. If I subtract another 8 pi over 4, that gives me pi over 4. So I'm going to rewrite that angle, and I'm going to say sine inverse of sine of pi over 4. Because I know that 17 pi over 4, if I went around the circle once, that's 8. If I go around again, that's 16. If I go one more, that gives me 17 pi over 4, and that's just 1 pi over 4 away. So 17 pi over 4 can be replaced by pi over 4, and now, since pi over 4 is in that restricted domain, the signs cancel, and I get pi over 4 is my answer. So sometimes it's nice because I know that I'm looking for inverse sine in quadrants 1 and 4. Sometimes it's nice that that angle falls within that restricted area. When we did example D, the angle fell down here in quadrant 4, which is not in my restricted area. So we had to find an angle that had a similar or an identical cosine value in that restricted area, which was in this case pi over 6. All right, so let's take a look at this last one. Tangent inverse of tangent of a negative 11 pi over negative 11 pi. So again, I know this is an angle, and that angle for tan has to be between negative pi over 2 and pi over 2. Well, negative 11 pi over 2 clearly is way too small. So I'm just going to find coterminal angles to get it on our chart. So I know this is 0, this is pi, this would be pi over 2, 2 pi, and then down here is 3 pi over 2. So if I add 2 pi, that gives me negative 9. If I add another 2 pi, that gives me negative 7 pi. If I add another 2 pi, that gives me negative 5. If I add another 2 pi, that gives me negative 3. If I add another 2 pi, that gives me negative 1. If I add another 2 pi, that gives me pi. So I know that negative 11 pi is the same as saying tan inverse of tan of pi. So if I added basically 12 pi, that gives me positive pi. Okay, so I have a problem here because tangent, we look from negative pi over 2 to pi over 2, but pi is all the way over here. So I have to find another angle that has the same tangent value of pi. Well, I know the ordered pair over here is negative 1, 0. So if I find tangent, which is y over x, I have to do 0 over negative 1, which is 0. So I have to find another angle in quadrant 1, or from quadrant 4 to quadrant 1, that has a tangent value of 0. Well, I know the only other place where tangent is 0 is right here at 0, because my ordered pair is 1 comma 0. So if I do 0 over 1, I get 0. So we're going to replace pi with 0 pi, or just 0. Can't use 2 pi because that's that's out of the range. So I'm going to get tangent inverse of tangent of 0 pi, or just 0. Those undo each other, and my answer is just 0, or we could call it 0 pi. Okay, so again, we always, if we can, we have to rewrite that angle to find a similar angle, or an angle within that restricted value. Okay, you cannot rewrite ratios. There is nothing else I can do to negative 12. So if I had cosine of cosine inverse of negative 12, negative 12 is not from negative 1 to 1, right? Because this is a ratio. So I cannot rewrite negative 12. So this answer would just be undefined. Okay, but angles I can rewrite. So again, we can rewrite angles. You cannot rewrite ratios. All right, so the last thing we're going to take a look at is what happens if it's not cosine, cosine inverse, or sine, sine inverse. Okay, these are actually a lot easier because these are going to all end up being unit circle values, which is why I put the unit circle on the right. So whenever we do composition of functions, which is all this is, we always start on the inside. So the first thing I have to do is I have to say, okay, what is sine inverse of root 3 over 2? So I know that this is a ratio, and I know that root 3 over 2 is between negative 1 and 1, right? Root 3 is 1.7, cut in half is smaller than 1, okay? And we know that sine is a y value. So basically what I'm saying is what angle has a y value of root 3 over 2? Since we're talking about sine, we need to look on the right side of the circle. Anything above 0, we can refer to as the angle itself. But remember, anything below 0, we have to refer to as a negative angle. Okay, so I'm looking for where sine is positive. Well, positive root 3 over 2 occurs right here. Okay, so I'm going to replace this whole part inside with pi over 3, because pi over 3 is the angle whose y value is root 3 over 2. Now the last step is I just have to drop that cosine down, and I'm just going to do cosine of pi over 3. Well, I know cosine is the x value. So what is the x value at pi over 3? It's just a half. So my final answer is 1/2. All right, so the next one, cotangent and tangent are not the same. So that's different than what we did a few minutes ago. And it says, okay, tangent inverse of 1. Well, I know this is a ratio. And for tangent, the ratios can be any number from negative infinity to infinity. So I'm good there. I know that my angle measure, though, has to be between negative pi over 2 to pi over 2. Any angle up here is going to be just the positive angle that you see. But any angle down here, we have to rewrite it as a negative angle. So 11 pi over 6 or 7 pi over 4 can never be answers. We have to refer to them as the negative angle. So I know that tangent is y over x. And I know in order to get 1, the y and the x value have to be the same. Well, tangent's positive up here in quadrant 1. So we got to look for where y and x are the same, which only happens at pi over 4. So I have to do cotangent of pi over 4, because pi over 4 replaced tangent inverse of -1. All right, so the last thing I have to do then is I have to do tangent of pi over 4. Well, tangent is just x over y. So if I take the x value divided by the y value, right, x over y, that's just root 2 over 2 divided by root 2 over 2. So that is 1. Is it a coincidence that it's the same up there? Absolutely, because cotangent and tangent are very similar. Sometimes it might be 1 or -1, but those do not undo each other because they are not inverse functions. All right, excuse me, let's take a look at the letter C. So cosine inverse of sine of -pi over 3. Okay, so now we've got sine, so I know this has to be an angle. So we just have to find sine of the angle. Well, the problem is that angle is not currently on our unit circle, so we want to keep adding 2 pi to get it there. So I'm going to add 6 pi over 3. That gives me -pi over 3. I want to add 6 pi over 3 again, so that gives me 5 pi over 3. So the first thing I have to do is I have to find sine of 5 pi over 3. Well, that's on my unit circle. It's actually right down here. So sine of 5 pi over 3 is the y value, right? Because we know that sine is the y value at pi over 3, which is -√3 over 2. Now, because this had a cosine inverse in front of it, now I have to do cosine inverse of -√3 over 2. Okay, so again, we do have to check the restrictions. This is from -1 to 1, because remember, this is a ratio. Okay, but we have already talked about that √3 over 2 is just 1.7 cut in half, which is smaller than 1. So we have to now look at cosine, and remember what we're looking for is we're looking for an angle from 0 to pi that has a cosine value that's negative. So if I look from 0 to pi, the only place cosine's negative is over here in quadrant 2. And where is the x value negative? It's negative at 5 pi over 6. So my final answer is the angle, which in this case from 0 to pi is 5 pi over 6. That's where the x value is -√3 over 2. All right, last example is sine, and then we have a secant inverse in front of it. But again, the first thing we have to do is we have to evaluate the inside. So sine of pi over 3, so let me erase them from the last one. So pi over 3 is right here, and we know sine is the y value. So the y value of pi over 3 is just √3 over 2. So I have to do the secant inverse of √3 over 2. Okay, now, we didn't learn anything yesterday about secant, but I do know something about cosine and secant, and I know if I just take the reciprocal, that gives me a 2 on top and a √3 on the bottom, right? If secant is √3 over 2, then cosine has to be the reciprocal, 2 over √3. So the only problem here is if you take your calculator and you divide 2 by 1.7, you're going to get a number that's bigger than 1. So since this has to be a ratio between -1 and 1, and if I take 2 and divide by 1.7, it's too big, right? It's not between -1 and 1. That means the answer to this one is undefined because cosine inverse has to be a ratio between -1 and 1. When I flipped secant, 2 divided by √3 is too big, so it doesn't work. All right, your homework is worksheet 7.2, day 1. Please make sure you show all work. Thanks.